put myself on camera, sorry. Alright, so first we're gonna do, f of g of x. So what's g of x equal to? G of x is equal to 1 over x plus 4. And now we evaluate f at 1 over x plus 4. So we just put 1 over x plus 4 in for x and f of x on the right hand side. And we have 1 over x plus 4 minus 4. Right? I just put 1 over x plus 4 in for x here. Okay? Well, this is now a complex fraction, right? This is the main fraction bar right here. 4 minus 4 is 0. So we're left with 1 over x. And whenever you divide 1 by a fraction, you're just taking the reciprocal of the fraction. 1 divided by 1 over x is just x. So we're half complete in proving that f and g are inverse functions of each other. Now we got to take the composition of g with f. G of f of x. F of x is equal to 1 over x minus 4. So g of 1 over x minus 4. What's g of 1 over x minus 4? We put 1 over x minus 4 in for x on the right hand side of g of x. And we have 1 divided by 1 over x minus 4 plus 4. Again, 1 is being divided by a fraction, a quotient. So when you divide 1 by a quotient, you just take the reciprocal of the quotient. What's the reciprocal of 1 over x minus 4? It's x minus 4 over 1. And x minus 4 over 1 is just x minus 4. We have minus 4 plus 4, which is 0. And so this is just equal to x. Okay? So f and g, right? So we can conclude f and g are inverse functions of each other. Okay? Any questions on that?
Can you explain how you got that again, the last part?
Which? Where?
X minus 4 plus
Here?
4? Yeah, where did you?
Oh, I went from here to here?
Mm-hmm.
So we have we have 1 divided by 1 over x minus 4, right? Remember, fraction bars are like division symbols. This is the main fraction bar. So we can write this as 1 divided by 1 over x minus 4. So remember, when you're doing division with fractions, you keep the first number, you switch division to multiplication, you flip the last fraction. So we keep the 1, change division to multiplication, and then we flip the second fraction. So we go from 1 over x minus 4 to x minus 4 over 1. Well, this times 1 is just itself, and x minus 4 over 1 is x minus 4. Okay? So keep, switch, flip, whenever we're doing division with fractions, okay? All right. Any other questions? Okay. So if you flip your page over, finding the inverse of a function, okay? So there are 4 steps involved. So you're given a one-to-one function, and you have to find its inverse function. There are 4 basic steps listed here. Okay? And so we're going to use those 4 basic steps in finding the inverse of a couple of one-to-one functions. Okay? So in example 4a, we have f of x is equal to 3x over x minus 4. Okay? So step number 1 is change f of x to y. Remember, y values and function values are the same. So y is equal to 3x over x minus 4. So we replace f of x with y. Okay. Step 2, switch x and y. So we replace y with x and x with y. Step 3, solve for y. Okay. So we have a quotient on the right-hand side, right? Dividing by y minus 4. What then does division? Multiplication, right? So we'll multiply both sides by y minus 4. We have x times y minus 4 on the left is equal to 3y over y minus 4 times y minus 4 on the right, right? So we solve for y. In the first step, we multiply by y minus 4. Okay? So the factors y minus 4 cancel on the right-hand side. Now on the left-hand side, all right, we gotta go from 2 y's to 1 y, right? In solving for y. So to do that, we gotta distribute the x inside the parentheses here. We have xy minus 4x is equal to 3y. Now we're going to group the terms with a y in them on the left and the terms without a y on the right. So, let's see, in this case, right, this step we distribute. And so we're going to subtract 3y, bring it to the left-hand side, and we're going to add 4x to both sides and put it on the right-hand side, right? 2 steps at once. So we have xy minus 3y is equal to 4x. So we subtract 3y and we add 4x to both sides, okay? Now we have a difference of terms, 2 terms here, and they each have a y in it, right? So we can factor out a y. So we have y times x minus 3 is equal to 4x. Okay. Now we have y times x minus 3. To isolate the y, we divide both sides by x minus 3. So we have y is equal to 4x divided by x minus 3. So we solved for y. And then the last step is to replace y with inverse function notation. So our one-to-one function's name is f. So our inverse function's name will be f inverse. So f inverse of x is equal to 4x over x minus 3. Okay? The last step, replace y with f inverse of x. Okay? So find an inverse. Right? So that's what goes into blank. Okay? At the bottom there. Okay? F inverse of x is equal to 4x over x minus 3. Okay? So that's the inverse function. Now, to find the domain of f of x, we know how to do that, right? I mean, that's exam 1 material. Here's f of x. Right? There's no square root, so you don't have to worry about square roots. But we have, this is a rational expression with x in the denominator. So you got to eliminate from the domain any values of x that make the denominator equal to 0, right? So one way to express the domain of f of x is that x minus 4 can equal 0. And then when you add 4 to both sides, you get x can equal 4. Right? So that's the domain in inequality notation. But in interval notation, okay, what you put in the blank here, okay, is minus infinity to 4, parentheses, union, parentheses, 4 to plus infinity. Okay, that's what goes in the blank. Right? That's the domain of f of x. Okay. Now that we know the domain of f of x, we automatically know the range of the inverse function. Okay? At the top of page 2, and I also did with the drawing this morning, okay? The domain of f and the range of f inverse are the same numbers, right? They're the same numbers. So the range of f inverse is that y can equal 4. Okay? So in interval notation, minus infinity, 4, union, 4, plus infinity. Okay? If you know the domain of f of x, you automatically know the range of the inverse function. Okay? Now to find the range of f of x, we just find the domain of the inverse function. And once we know the domain of the inverse function, we automatically know the range of f of x. Well, here's the inverse function. There's no square roots in it, but it is a rational expression with x in the denominator. And so, if any value of x that makes the denominator equal 0 is not in the domain, right? So we set x minus 3 as the denominator, not equal to 0, right? That's one way to express the domain. You add 3 to both sides, get x can equal 3. So how do you write that in interval notation? Minus infinity 3 parentheses, union parentheses, 3 infinities. That's the domain of the inverse function. X can equal 3. So what's the range of f of x? All real numbers except the number 3. Y can equal 3. Interval notation, minus infinity to 3 parentheses, union parentheses, 3 plus infinity. Once you know the domain of the inverse function, you automatically know the range of f of x. Okay? Any questions on that, ladies and gentlemen? Okay. All right, let's take a look at B. Going to do the same thing. We have f of x is equal to the square root of 2x minus 3. Okay. All right, so to find the inverse function, step 1, replace f of x with y. Step 2, same 4 steps every time. Every time. Step 2, switch x and y. So we have x, the square root of 2y minus 3. Step 3, solve for y, right? So we're going to add 3 to both sides. We have x plus 3 is equal to square root of 2y. What does square root? Squaring, right? So we square the left. And we square the right. So we have x plus 3 squared on the left is equal to 2y on the right. And now, right, you can divide both sides by 2. Then we switch the 2 sides. Now, instead of dividing by 2, I prefer to multiply by 1/2. But you can leave it as written as dividing by 2 if you want. I don't care. Yeah. Division by 2 and multiplication by 1/2 are the same thing. Okay? And then what's the last step? Replace y with inverse function notation, right? So the name of our one-to-one function is f. So we have f inverse of x is equal to 1/2 times x plus 3 squared. Okay? What's the graph of this going to be? Is a parabola a one-to-one function? No. So this domain is restricted. It's not all real numbers. Okay, it's not all real numbers. Okay. So we'll do things a little bit differently with this one. to show that the domain is not all real numbers, because you know a U-shaped parabola fails the horizontal line test. Okay. All right. Domain of f of x. Well, f of x is equal to square root of 2x minus 3. So we don't have a rational expression of x in the denominator, but we do have a square root. And that, what's the restriction on the radicand? It has to be what? Non-negative is a better term, because it can equal 0. So it has to be greater than or equal to 0, right? So we set the radicand greater than or equal to 0. When you divide both sides by 2, you get x is greater than or equal to 0. Okay. So in interval notation, the domain is bracket 0, infinity. Okay. So now we know the range of the inverse function, right? Same numbers applied to y, 0 to infinity, right? Y is greater than or equal to 0. Okay? You know the domain of the one-to-one function, you automatically know the range of the inverse function. Okay? Now here's the tricky part. The domain of the inverse function. It's not all real numbers, because you graph this and you get a U-shaped parabola and it fails the horizontal line test. It has to pass the horizontal line test. Okay? So how am I going to rationalize this? Oh, so you're given a coordinate plane, right? And so let's graph f of x. F of x is equal to square root of 2x minus 3, right? And so let's make some observations here first, okay? F of 0, if I put 0 in for x, f of 0, I have 2 times 0, which is 0. Square root of 0 is 0, and 0 minus 3 is negative 3. F of 2, if I put in 2 in for x, f of 2, right? Then I have 2 times 2, which is 4. Square root of 4 is 2, and 2 minus 3 is negative 1. So f of 2 is equal to negative 1. Are these points on the graph of f of x? Yeah, right? This is the x coordinate, that's the y coordinate. And then f of 8, I put 8 in for x, I have 2 times 8, which is 16. Square root of 16 is 4. 4 minus 3 is 1. So f of 8 is equal to 1. Okay? So I can plot those 3 points in the coordinate plane, right? If I connect the dots to get the graph of f of x. Okay? So x-axis, y-axis. Okay? So 0 minus 3 is a point on the graph, and 2 minus 1 is a point on the graph, and 8, 1 is a point on the graph of f of x. Okay? So you're provided, right, with x and y axis, you have to provide your own hash marks. So here's the point 0 minus 3. Right, 3 units down from the origin. And then two minus 1. So here's 1, 2, 3. So here's 2 and then minus 1. So here's the point 2 minus 1 in the coordinate plane, my coordinate plane. And then 8 and 1. So 1, 2, 3, 4, 5, 6, 7, 8. And then here's y equals 1. So here's the point 8, 1. Okay? And now you play connect the dots. And the graph of f of x looks something like that. Okay? Crudely drawn. Okay? So this is the point 8, 1. This is the point 2, 1. And this is the point 0, 3. Okay? Are you with me? To be able to do this, this is a perfect exam question. Okay? Do we know how to draw the inverse function now? What do we got to do to draw the inverse function? So, yeah, that's all we do, right? Flip the x and y coordinates. So on the inverse function, right, instead of 0, 3, we have the point 3, 0. Oh, excuse me. Did you see the mistake I made? What's wrong here? Yeah, it's positive 3. It should be minus 3. You were supposed to tell me that. Right? 0 minus 3. So on the inverse function, we have the point minus 3, 0. So we have minus 1, minus 2, minus 3. So it's an x coordinate, or it's an x intercept. And then when we switch to 1, we get 1, 2. So here's x equals 1, here's y equals 2. That point right there. And then 8, 1. Dadgummit, Robert. You guys are supposed to be telling me to wake up. For some reason, when I applied the points, I left off the minus signs. So 0 minus 3, 2 minus 1, and 8, 1. So when we flip these, we get minus 3, 0, which is right there. When we flip these, we get minus 1, 2, which is right here. Okay? And then when we flip these coordinates, we get 1, 8. So here's x equals 1. So we get 1, 2, 3, 4, 5, 6, 7, 8. Okay? Remember, the inverse function and the one-to-one function are symmetric about what line? Y equals x, right? So f of x is a mirror image of f inverse, and f inverse is a mirror image of f of x across this line y, diagonal line y equals x. Okay? So here's the point minus 3, 0 on the inverse function. Here's the point minus 1, 2. And here is the point one 8 on the inverse function. Okay? Now riddle me this. Okay? What's the domain of the inverse function? Those are the x coordinates. What's the smallest x coordinate? What's the largest x coordinate? Right? So it's not all real numbers. It's just greater than or equal to -3. Right? So the domain of the inverse function is x greater than or equal to -3. Right? That's the minimum x coordinate. There's no maximum x coordinate. And so in interval notation, bracket -3 to infinity. Okay? Now you know the range of f of x, which you can also get from the graph, right? The smallest y coordinate graph of f of x is -3, and there's no maximum y coordinate. Y is greater than or equal to -3. Okay? So this is one of those cases where when you look at this, you see, okay, that's, for all values for all real numbers, the graph of that is a parabola that can't be right. So the domain must be restricted. And it is. When we graph it, the inverse function based off f of x, we see that the domain of the inverse function is just from -3 to infinity. It's like the right half of the parabola. Okay. This is like the right half of the parabola. It doesn't have the left half. Okay. All right. Any questions on that? So I was gonna start new material for exam 3, 2.9, but I think we'll just stop right here. Okay. And the printer was on the fritz Friday, so I couldn't print out 2.9 anyway. So remember, Wednesday there's a quiz because we have the test on Thursday, and the quiz will be over. So we did 2.3 and 2.4 last time, right? So the quiz will be over 2.5 and 2.6, but not 2.8 because the 2.8 homework is due Wednesday night, not before class. Okay? Are you with me? I forgot to write it on the board. Quiz will be over 2.5 and 2.6. Okay? So I'll see you Wednesday.
Okay. What is the